Hello everybody, welcome into another lesson. So today we are going to talk about arithmetic series. And this builds off of arithmetic sequence in the fact that this time, instead of just a list of numbers, we're going to add all the numbers together, like in general what a series is. But let's consider this series 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20. Now, if you want to, you're more than welcome just to add all these numbers straight together and get an answer. Now, that's all fine and dandy, but let's say this series went on considerably longer, we went into the hundreds. Are you really going to want to sit there and add that many numbers? I don't think you are, and we're going to demonstrate this with some of these exercises we're going to do today. If it's an arithmetic series, there is a shortcut. So we have, from the introduction to series lesson, we talked about the sigma notation, right? Where you start with your index of summation, usually at 1, going to your upper limit of summation of, in this case, would be your arithmetic sequence, the sum of that. It's often written as S sub n to indicate a sum. If you want to find the sum of that series, if it's an arithmetic series, you take that n, which is your upper limit of summation, times the quantity of your first term plus your final term, all that divided by 2. So in this particular series, it might help us to first treat this as a sequence and write out the general formula for the sequence. Okay, so let's look at the pattern here. Pretend the plus signs aren't there. Instead we have commas here, treating this as a sequence. So you notice that between every single one of these terms there's a common difference of 2, right? It goes up by 2. So my common difference is 2. My first term is 2. A sub 1 equals 2. Let's find the explicit formula for the general nth term of the sequence. Well, remember, that's going to be my a sub 1 plus my n minus 1 times d, right? Okay, so in this case, a sub 1 was 2 plus my n minus 1 times my common difference of 2. This would simplify into 2 plus 2n minus 2, which means a sub n is just simply 2n. So I have just found my sequence. We can take the sequence and write it into the series. So this would be the sum from I equals 1, and we're going up to 10 terms. If you count it, there's 10 terms, so my upper limit of summation is 10 of this a sub n, which is 2n. Alright. Now, all I have to do to find this particular sum is take the number of terms I have, my upper limit of summation, in this case is 10, times my first term, which is going to be found to be 2, plus my 10th term, in this case, which was 20, we have it, divide all that by 2. That's going to simplify into 10 times 22 all over 2, which could be the same as 10 times 11, or simply 110. And if you sit there and add all these numbers together, you'll also get 110, but this is a much quicker way. What if we had 500 terms we were adding? Are you going to want to sit there all day and add up 500 terms? I don't think you are. This is a much shorter way to get the same result. We get 110 for the sum of this particular series. And this formula only applies to arithmetic series. If it's not arithmetic, this formula is not going to work. So let's go ahead and do some more of these. Let's say we have 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19. So we got 1 plus 4 plus 7 plus 10 plus 13 plus 16 plus 19. Alright, well, we can definitely see here, if we look between each of these terms, we have a common difference of 3, right? It goes up by 3 each term. Since we have a common difference, this is an arithmetic series. And our first term itself is 1, so a sub 1 equals 1. Next thing to do is find the general explicit formula for the nth term of the sequence. Treat this as a sequence for a minute. So a sub n is going to equal my a sub 1, which is 1, plus that n minus 1 times my common difference of 3. So that's going to equal 1 plus 3n minus 3, which means a sub n is going to end up equaling 3n minus 2. Now we have found the general formula for the nth term of the sequence. Let's take this and express this as a sum. So we know our index of summation is 1, so I is going to equal 1. Now how many terms are there? Just count them. 1, 2, 3, 4, 5, 6, 7. So we got 7 terms. And then just put in your a sub n for what you're taking the sum of. That would be 3n minus 2. Now we want to take the sum of that, which you could write as s sub 7, because that's how many terms we're taking the sum of. Now again, since this is an arithmetic series, this formula here will apply. So that n is going to be 7, since there are 7 terms, times my a sub 1, which is 1, plus my a sub 7, which was 19, all that divided by 2, which is going to be 7 times 20 divided by 2, which could simplify into 7 times 10, which is going to give me 70. So the particular sum of this series would end up being 70. Once we convert it, we'll end up getting 70. Let's do another one here. Let's say we have -1 plus -3 plus -5 plus -7 plus -9. I tell you what, why don't we count out the number of terms there are? So we have 1, 2, 3, 4, 5 terms, right? That means my n is going to equal 5 because I have 5 terms. Now, do I have a common difference? Is this going to be an arithmetic series? Well, if I look between each term, I'm going down by 2. So I do have a common difference of -2. So my common difference is -2. This is an arithmetic series. My first term is -1. So a sub 1 equals -1. Now I have enough to at least find the general explicit formula for the nth term of the sequence. So a sub n is going to end up being my first term, that -1, plus the quantity of n minus 1, times my common difference of -2. Let's simplify this. We'll have -1 minus 2n plus 2, which means my final simplified format is going to end up being 1 minus 2n. That's the formula for the sequence, would be 1 minus 2n. Now all I need to do is take this and convert it into sigma notation. So my index of summation is 1, so we'll have I equals 1 below the sigma sign. We've determined that there are 5 terms, n equals 5, so we'll have a 5 here. And then our a sub n is going to be 1 minus 2n. Alright, so now we can go ahead and find our sum, which is going to be s sub 5, since there are 5 terms. Well, applying this formula, we'll put the 5 in for the n, times our first term, a sub 1, which is -1, plus a sub n, which is our a sub 5, that's -9. So -1 plus -9 is the same as -1 minus 9. All that divided by 2. That turns into 5 times -10 divided by 2, which could simplify into 5 times -5, giving me the sum for this series to be -25. So the sum for this particular series is going to be -25. And it might have just been quicker to add them, but in a minute or so you're going to be thankful we have that formula. And I'm going to show you why. So let's say you have something like this. You have the sum from n equals 1 to 50 of n. So they want you to find the sum of 50 terms from n equals 1 to 50 of n. Are you really going to want to sit there and add up 50 terms? I don't think you are somehow. So this is definitely an arithmetic sequence. Everything we're going to do here is an arithmetic series, rather. So we don't have to worry about that. This formula will apply. Well, this is the same as the sum of the first 50 terms. So our n, which is our upper limit of summation, is 50. We'll have 50 times our a sub 1, which is just simply 1, because if you put in 1 for n, you get 1, plus a sub n, that's your upper limit of summation, a sub 50. Well, if you put in 50 for n, you simply get 50. Then you divide all that by 2. Well, that's going to give you 50 times 51 divided by 2, which would simplify into 25 times 51, and then we can get an answer. You get 1,275. So the sum of this series is going to be 1,275. Much better to do it this way than writing out 50 frickin' terms and adding them all up. Alright. Now, what if I had something like this? From n equals 1 to 200 of 2n. This is definitely an arithmetic series, but this time we're going to do the first 200 terms. Don't think anyone here is opting to write out 200 terms and then add them in a calculator. here is a trick with whenever you have a series where you have a coefficient on a variable, it's literally the exact same thing as taking that coefficient outside of your sum from n equals 1 to 200 of n. It's literally going to be the exact same thing. You can take that coefficient on the variable, take it outside of your sigma, and then you'll multiply the sum by that too. It works the exact same way for when you have a sum. So having said that, let's do this. So let's see. It would probably help if I identify my first term and my 200th term, right? A sub 1, I just put that in for n, I'll simply end up getting 1. If I want my 200th term, a sub 200, put that in for n, I'll end up getting 200. Now I've identified a sub 1 and a sub n. N's obviously 200, my upper limit of summation. So this is going to be equal to 2 times my sum. The formula for the sum is my n, which in this case is my upper limit of summation, that 200, times my a sub 1, which is going to be 1, plus my a sub n, which is a sub 200, that's 200, all over 2. Well, these 2's would cancel out. This should just end up being 200 times 201. Let's go ahead and do the multiplication. It's going to be a really big number, I can tell you that. You get 40,200. So the sum of this series is going to end up being 40,200. Let's do one more like it. Let's do a couple more like it. All right, so we have the sum from n equals 1 to 100 of 5n. So we have the sum from n equals 1 to 100 of 5n. Since I have a coefficient on my n, that's the same thing as taking that coefficient outside of this sum, putting it outside of the sigma, and then putting just the variable inside of the sigma from n equals 1 to 100. So that's going to be 5 times this sum. It'll be 5 times that sum. You can do that again with variables whenever you have a coefficient on them. Alright, well first let's find our a sub 1. That's going to end up being, if we just look at the n, a sub 1, put in 1 for n, you get 1. A sub 100, since we're going up to the first 100 terms, 100 in for n, you just get 100. Alright, so this is going to be the same thing as taking 5 times the sum. So 5 times, we're going to the upper limit of summation of 100. So we'll put in 100 for n, times my a sub 1, which is 1, plus my a sub 100, which is 100. All that divided by 2. Well, this could simplify into 5 times 50 times 101, which would end up giving me 250 times 101. That's going to be another big number. I get 25,250. So the sum of this particular series is going to be 25,250. Now let's change this on you a bit here. Let's change the index of summation. Alright, so n equals 51. That's our index of summation is 51 to 100 of 7n. Alright, well, notice we're not starting at 1, we're starting at 51. Let's deal with that 51 in a second. First, we know we have a coefficient on the n. We know we can move that coefficient outside of the sigma and take that and multiply it by the sum from n equals 51 to 100 of n. This will be 7 times that sum of n. Okay. Now, we're definitely going to want to find our first term. Since we're starting at 51, a sub 1 is really going to be a sub 51. If I just put in 51 for n, I'll end up getting 51. And then a sub n is still 100. I'm going to put in a sub 100. We'll end up getting 100. But how many terms do we actually have? We go only from 51 to 100. There's actually 50 terms, right? If you take 100 minus 51, you get 49, but you actually got to add 1 because you got to count that 51, so you get 50 terms. So n is going to equal 50. There are actually 50 terms, so they do try to trick you sometimes. But that's how you're going to approach sums whenever it doesn't start at 1. So let's take 7, because that 7's outside of the sigma, times our n, which in this case is 50. We're only doing it for 50 terms. Times, we started at 51, so that'll be times 51 plus our a sub 100, which is 100. All that divided by 2, well, that's going to be the same as 7 times 25 times 151, which is going to equal 175 times 151. Now we should be able to get a sum. You get 26,425. So the sum of this particular series would be 26,425. Okay. Let's change it up on you a bit again here. Let's say you have a difference of two sums. Alright, so what do we got here? We have a difference of two sums. The first one is from n equals 11 to 30 of n minus n equals 1 to 10 of n. This looks horrible, but it's really not. You can actually evaluate these sums separately. Let's start with the sum from n equals 11 to 30 of n. So let's just focus on that for now. N equals 11 to 30 of n. Alright, well, we definitely, our first term, since we're starting at a sub 11, a sub 11 is going to be, of course, 11 if we put that in for n, right? Then a sub 30, that's going to be our upper limit of summation. 30 n for n will just give you 30. Now, n doesn't start at 1, it starts at 11, so we need to actually figure out how many terms there are. If you take 30 minus 11, you get 19, but you got to add 1 because you have to count that 11. There's actually 20 terms. So n is going to equal 20. Now we can consider taking this sum. That's going to equal this formula here of this formula. So the n in this case is 20. That's for how many terms we're taking, times our first term, which is 11, plus our last term, which is 30. All that divided by 2. Well, that's going to give you 10 times 41, which should just give you 410, right? We just found our first sum to be 410. Now we need to deal with the second sum of from 1 to 10 of n. So this one's going to be a little bit easier. The sum from n equals 1 to 10 of n. Well, we definitely want to find a sub 1. It does start at 1 this time, so a sub 1 equals 1. We go up to 10, so a sub 10 is going to equal 10. And we actually truly have 10 terms this time. We truly do have 10 terms. So this is going to make this a lot easier. So we'll use the formula. We're going to have 10 times our first term of 1 plus our second term, plus our last term rather, of 10 divided by 2. Well, that's going to give us then 5 times 11, which would just give us 55. Now that we know both of these sums, we can do the subtraction. So this really all equals 410 minus 55, which should equal 355. So once you figure out both sums separately, you can just take the difference of the two sums and you should end up getting 355. Let's do another one like it. So you have the sum from n equals 51 to 100 of n minus the sum from n equals 1 to 50 of n. Alright, so you have the sum from n equals 51 to 100 of n minus the sum from n equals 1 to 50 of n. The thing to do again is figure out each of these sums separately, then do your subtraction. So let's deal with this first one, n equals 51 to 100. So let's just look at that one for now. N equals 51 to 100 of n. Well, our first term in this case, since we start at 51, would end up being a sub 51. Just put in 51 for n, you get 51. We're going to 100, so a sub 100 is going to equal 100. But how many actual terms are there really? 100 minus 51 is 49. If you count that 51, you got to add 1, so there's actually 50 terms. So n's going to equal 50. Now we can consider taking this sum. So we'll put in 50 for our n times that first term, which is a sub 51. That'll be 51 plus the last term, a sub 100. That's 100 all over 2. Well, that would be 25 times 151, which we'll be able to figure out the first sum here very shortly. That gives us 3,775. So this first sum is 3,775. Now we can figure out the sum from 1 to 50 of n. So let's look at that. So the sum from n equals 1 to 50 of n. Alright, well, our first term, a sub 1, just put in 1 for the n, you get 1. Put in your last term, the 50, a sub 50 for the n, that would give you 50. Alright, now, in this case, the number of terms is easy because we start at 1 and go to 50, so there's actually 50 terms this time. Now we can apply this formula. So we have 50 terms times the quantity of your first term, which is 1, plus your last term, which is 50, divided by 2. So that's going to give you 25 times 51. Let's see what that is. That's 1,275. Now that we know both of these sums individually, we can just do the subtraction. So we can take 3,775 minus 1,275, and we should end up getting 2,500 or 2,500. So your final answer should end up being 2,500. Let's do one more simpler one here, and then we'll do some partial sums. And I'll explain about infinite arithmetic series. Alright, so we have the sum from n equals 1 to 500 of n plus 8. So we have the sum from n equals 1 to 500 of n plus 8. So at least n starts at 1. So if we want to find a sub 1, that's going to end up being, then you put in 1 for your n, so 1 plus 8 equals 9. So a sub 1 is 9. Now we need to find a sub 500. So you put in 500 for your n, so 500 plus 8 equals 508. And then we can definitely see that there are 500 terms because it goes from 1 to 500, so n is going to equal 500. Now we can go ahead and apply the formula since we know that information. So we'll take that n being 500 times the sum of our first term, which is 9, plus our last term, which is 508, all that divided by 2. So that's going to simplify into 250 times 517. And I bet you're glad we have the formula. Would you want to sit here and write out 500 terms and add them? I don't think you would. So 250 times 517, you get 129,250. So you end up getting the sum of this series being 129,250 with the shortcut formula. Alright, now let's talk for a moment about infinite arithmetic series. Let's just say we're given a series from 8, 20, 32, 44, and it just keeps on going and going, right? We're going to make a series out of this. Granted, we have a sequence that doesn't stop. We want to find the sum of this sequence, which in other words is a series. Well, if we look between each of these terms, we definitely have a common difference, right? The common difference between each term is 12. 8, 20, 32, 44 keeps going. The common difference between each term is 12. We even know the first term is 8, right? Let's take this to a sigma notation. First, let's find the formula for the sequence. So a sub n is going to equal my a sub 1, which is 8, plus that quantity of n minus 1 times d, which is 12, which equals 8 plus 12n minus 12, which should end up giving me 12n minus 4. So we found a sub n to be 12n minus 4. Now we can take this and put it into a sigma notation. We'll, of course, go from n equals 1. We're starting with the first term. But notice, this sequence, which in turn turns into a series, since we're adding it, just keeps on going and going and going. This is actually an infinite arithmetic series of this a sub n, which is 12n minus 4. Well, here's the problem. If I keep taking the next term, adding 12, adding 12, adding 12, the numbers are just going to keep getting bigger and bigger and bigger. It's never going to reach a finite answer, right? You would say this is divergent. The reason being, it diverges or is divergent because it doesn't converge to a finite answer. So if you ever have a infinite arithmetic series, it'll never converge. It always diverges. It can diverge towards positive infinity or negative infinity, depending upon what your numbers are, but they're always going to diverge. Now, once we talk about geometric series, it is possible to have an infinite geometric series and get a finite answer, but that's a couple lessons from now. But for arithmetic series, you can never get a finite answer. It's always going to diverge. But we can take what's called a partial sum, which we talked about a couple lessons ago in Introduction to Series. If they tell you to take the 10th partial sum, that n equals 10, we're taking the 10th partial sum, that becomes our upper limit of summation. We can certainly take a partial sum, right? Now all we got to do is find the first term, so that's going to, of course, be 12 times 1 minus 4, which would end up equaling 12 minus 4, which is 8. The first term is 8. Then we can find the 10th term, so a sub 10 equals 12 times 10 minus 4. That equals 120 minus 4, which is going to be 116. So we found the first and 10th term, and we know that there's 10 terms, right? Now we can apply this formula, n equals 10, times our first term of 8, plus our 10th term of 116, all that divided by 2, which is going to equal 5 times 124. Let's take 5 times 124. You get 620. So the 10th partial sum of this series is going to be 620. But you could never take an infinite sum for an arithmetic series. It'll always diverge. It never converges to a finite number. Let's do one more. Alright, so we have 4.2, 3.7, 3.2, 2.7, And it's just going to keep going and going and going. Granted, this started as a sequence, but it's going to turn into a series because we're going to add it. If you look between each of the terms, we do have a common difference. Between 4.2 and 3.7, you have a difference of negative 0.5. Same between 3.7 and 3.2, and 3.2 and 2.7. So your common difference equals negative 0.5, and our first term is 4.2, right? So that's a sub 1. Now, let's find the general formula for the nth term of the sequence first before we try to evaluate the sum. So a sub n equals my first term of a sub 1, which is 4.2, plus that n minus 1 times my common difference of negative 0.5, which would simplify into 4.2 minus 0.5n plus 0.5, which for my final simplification is 4.7 minus 0.5n. Alright, so there's the formula for the sequence. Now we need to convert this to sigma notation because we're actually going to add all this together. So we're definitely going to start at 1, right? But here's the thing. If we turn this into a series, it just keeps going and going and going. It doesn't stop. So my upper limit of summation would be infinity of my a sub n, which is 4.7 minus 0.5n. And actually, in the end, I'll end up going towards negative infinity because the numbers keep getting smaller and smaller and smaller. I would end up going towards negative infinity, which still diverges. We can't define what negative infinity is. This would diverge because we can't come to a finite answer. But again, we can take a partial sum. This time they want us to take the 12th partial sum, where n equals 12. If we're to take the 12th partial sum, we change an upper limit of summation to a 12. We can certainly do that, right? A sub 1 we already know to be 4.2. But what is a sub 12? That number we don't know. A sub 12, well, that's going to be 4.7 minus 0.5 times 12. This would simplify into 4.7 minus 6, which should give us negative 1.3. So my 12th term is actually negative 1.3. And of course we know there's 12 terms, so we can easily find the sum. So what we have here now for this formula, n is 12, so we'll take 12 times my a sub 1, which is 4.2, plus my 12th term, plus minus 1.3 turns into minus 1.3. All that divided by 2, which would simplify into 6 times 2.9, which I should be able to get a final answer here in a second. I get 17.4. So the sum of my first 12 terms end up going to 17.4. But if I kept going, eventually I would reach the negatives and get towards negative infinity. But that's it for this lesson. Next lesson we'll dive into the geometric side. We'll get into geometric sequences next. So I hope everyone has a great day. And to all my American friends, happy 4th of July. Take care.